Hi, this is Someshwar Rao. Now we are discussing about JEE Main 2023 January 21st morning session paper. Let's go to the paper discussion. Electronic configuration of ND plus 2. Electronic configuration of ND plus 2. This is neodymium ND. This is atomic number 60 and it belongs to lanthanide 4F lanthanoids. So cerium, praseodymium, neodymium, pramotium, samarium, europium, gadolinium, terbium, dysprosium, like these are the elements. I am taking first half. Then this is 58, 59, 60, 61, 62, 63, 64. Then this is 4F1, 5D, 1, 6S2. Okay. Next one is 4F3, 5D, 0, 6S2. That means this electron, what is the expected is 4F2, 5D, 1, 6S2. This electron is transferred to here. Then this is not correct. This is correct. Next one is 4F14, 5D0, 6S2. Then this is 4F5, this is 4F6, 4F7, 4F7. This is first half electronic configuration of lanthanides. We want ND. So this is ND plus 2. ND plus 2. So loss of 2 electrons, that is 4F4, 5D 0, 6S 0. So what is the option? This is ND neodymium belongs to lanthanide and 4F series. Clear? Next one. The methods not involved in the concentration of the ore are. Concentration of methods are, what are those generally used? Hydraulic washing. Second one is magnetic separation. Next one is froth flotation. Next one is leaching process. These four are concentration methods. Concentration of ore. So here is not. That is why this is not, this is yes, is not, this is yes, this is yes. So wrong means what is that? A and C. What is the A and C? This is this one. Is it clear? Next one. Consider the propanol plus methanol is treated with diluted NaOH and heat. Diluted NaOH and heat is nothing but this is aldol condensation. This is aldol condensation. So what is the first product? CH3 CH2CHO plus formaldehyde. This here alpha hydrogens and oxygen is removed. This is aldol product, diluted NaOH and heat, that is aldol condensation. Due to aldol condensation, what is the product? Alpha beta unsaturated carbonyl compound. So this is what is the compound? CH3, C here double bond CH2 CHO. This is alpha beta, or how to write this one? CH2 double bond C here CHO, here single bond CH3. This is alpha beta unsaturated compound. This is alpha beta unsaturated compound. This is called aldol product. Aldol product. This is okay. What is the next one? NaCN. That is nucleophilic addition reaction. That is nucleophilic addition reaction. What is the nucleophilic addition reaction? CH2, this is CH2 double bond C, CH3 C double bond OH. In this one, this is here migrated towards oxygen is I electronegativity atom, is a minus, this is a plus, then H plus or Na plus and Cn minus, that is nucleophilic addition reactions. Okay, so what is that? CH2 double bond C, CH3, in this one, this minus plus O minus, here Na plus, this is a Cn and H, this is a H. This is subjected to hydrolysis, acidic hydrolysis. What is the reaction? Nucleophilic addition reaction. Next one is hydrolysis. Hydrolysis. Due to hydrolysis, what happened? Cyanide group is converted into carboxylic acid. In this one, byproduct is ammonia. So CH2 double bond C, CH3, here COH, hydrogen COOH. This is a product. So what is the required? In this one, chiral carbon is there, is the chiral center. Then optically active and optically active, this is a racemic mixture will be formed. This is a racemic mixture, then plus or minus. So this is incorrect. Here optically active is not correct, because is a chiral center is there, 50% extro, 50% levo. This is a racemic mixture is nothing but what is that? Optically inactive. So optically active, this is a wrong. What is the next one? Racemic mixture, and then is a neutral. Neutral, no, is a acidic compound. So this is a wrong. Racemic mixture gives with saturated, then racemic mixture, and what is that? Carboxylic group is there. This is treated with sodium bicarbonate to form CO2 gas. This is a correct. What is the next one? Next one is optically active alcohol, is a wrong. So answer is here 3. Clear? Next one. The correct order of basicity of oxides of vanadium. General metal with lower oxidation state is a basic character. Next one is metal with highest oxidation state is acidic character. But is vanadium Here V2O5, what is the oxygen state of this one? Here oxygen state equal to +3. Here what is the oxygen state? +4. Here oxygen state is a +5. Then vanadium is a V2O5. This is an amphoteric compound. Amphoteric. In this one, acidic character is there. Acidic character is there and basic character. And acidic character is dominated than basic character. This is amphoteric. In this one, this is amphoteric. 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 In this one, acidic character is dominated than basic character. Compound is amphoteric, but more acidic character is there. Then here generally one is a general concept, but here is valid or not? Here okay. This is oxygen state increases, acidic character increases, basic character decreases. But here acidic character is there, amphoteric character also there. So compound is amphoteric. That is the main point. Amphoteric. So percentage of oxygen increases, acidic character, acidic nature increases, basic nature decreases. So answer is this one. Clear? V2O5 is amphoteric oxide. In that one, acidic character also there. Compared to basic character, acidic character dominated. Okay. Next one. Cu+2 ion is treated with potassium iodide. White precipitate is formed. Then this solution is treated with sodium thiosulfate. Compound Y is formed. What is the X and Y? So here Cu+2 reacts with potassium iodide. We get Cu(I2) is extremely unstable because I- ion is a strong reducing agent and 2K plus is a first step. So is unstable. What happened? This is this one. Cu(I2) gives rise to Cu2I2 is a stable because this reducing agent changes to Cu+2 ion is reduces to Cu plus, here cupric to cuprous, and then iodine. Then this is white PPT, and then here iodine and potassium, already potassium iodide is there, no? Then one more compound is potassium iodide plus then I2 gives rise to Ki3, that is, this is nothing but K plus and I3 minus. This is brown color or pale yellow color compound, color solution. Then next one is here this iodine treated with iodine reacts with hypo Na2S2O3 gives rise to 2NaI plus what is that? Iodometry. Then Na2S4O6 sodium tetrathionate will be formed. So this is a reaction. What is the X? H2 Cu2I2. Then what is the Y? This is, what is the answer for this one? Answer is Cu2. This is the option. Clear? Okay. Next one. What is a compound? Nitrobenzene. This also known as oil of merbene. Nitrobenzene or oil of merbene. Then is treated with H2 in the presence of palladium. H2 in the presence of palladium. H2 in the presence of palladium means what is the reduction? Reduction. Then 6 hydrogens, we get aniline. Compound is aniline. NH2. Aniline. What is that? This is A. Okay, na? Now is treated with what is the compound? Acetic anhydride, CH3, C double bond O, CH3, C double bond O in the presence of pyridine. That means acetylation. This is acetylation of aniline. Acetylation of aniline. Then what happened? This group is separated out. This hydrogen, this is removed as minus CH3, COOH, and then remaining part is, what is the remaining part? Then COCH3. That is okay, no? N-phenyl estamide. What is the compound name? N-phenyl estamide. Estamide. What is the meaning? That is CH3, C double bond, N, here pH. That is okay. So what is the option of this one? This is the option. Okay, na? Nitrobenzene subjected to reduction. This is subjected to acetylation. Okay. Next one. Then cobalt chloride. You take a cobalt chloride. Cobalt chloride. COCl2 treated with H2O. Then we get octahedral complex. What is that? CO H2O taken 6, here Cl2. This is pink color. Then he said that this is, it forms pink color. This is a pink color. What is the pink color compound? This is a X. This is octahedral complexes. What is the coordination number? Coordination number equal to 6. This is octahedral complex. Octahedral complex. This is a X. Is it clear? What is the next one? It has, this solution is treated with a concentrated HCl, deep blue colored solution. Then what is the compound? CO H2O taken 6, Cl2, then plus concentrated HCl, that means concentrated HCl. Then CO H2O taken 6, here plus 2 plus concentrated HCl is the 4 concentrated HCl to get COCl4, here plus 2, this minus, this is a minus 2 plus 6H2O, that is a compound. So this is coordination number 4. Ligand is weak, that's why is involved in sp3 hybridization, tetrahedral. Then what the color is a deep blue color. So cobalt chloride with water to form pink color. This is octahedral complex. But is it treated with concentrated HCl, then chloride ion and water, their exchanges to form cobalt, that is a tetrachlorido cobaltate 2 complex. That is a coordination number, what is that, 4. And this is a weak ligand, sp3 hybridization, tetrahedral, that color is a deep blue color. So this is what is the required. Then what is the X, what is the Y? Y is, what is the deep blue color. And then what is the geometry? So answer is 6 COCl4 tetrahedral. What is the answer? This is the answer. Answer is 1. Is it clear? The next one. Identify the x, y and z in the following equation. So here ClO is a free radical. Then NO2, this also paramagnetic. This is a paramagnetic. This is involved in NO2, involved in sp2 hybridization, bent shape, paramagnetic, and its bond angle is 132 degrees. It has a special bond, N double bond. Here odd electron bond is there, then odd electron bond. So its bond angle is 132, is a special compound. This is generally is sp2. What is the bond angle? This is 120 degrees original value, but this value is greater than original value. What is the reason? Repulsion between pi electrons and odd electron bond is a paramagnetic. So this is a paramagnetic. This is also paramagnetic. So is a combined to form ClONO2. That is a X. That is a X. Okay, now next one is what is the next? This is treated with water. NO2 is treated with water. What are the two parts in water? This is a hydrogen, this is OH. That means hypochlorous acid is a good and strong oxidizing agent, plus what is that? HNO3. So both are oxidizing agent. In these two, what is the strong oxidizing agent? This is a strong oxidizing agent. Okay, now and then here what is the X and Y? This is a X, and then Y and Z. One is a hypochlorous acid, and what is the option? This is the option. This is here Y, and this is a Z. Clear? Okay. Next one. The correct order of melting point of dichlorobenzene. Then melting point depends on packing capacity. That's why here this is packing capacity order is ortho greater than, generally this is what is that? Ortho. Here meta, this is a para. Packing capacity order is para greater than, ortho greater than, this is meta. Therefore, what is the melting point order? Melting point order is, this is here Cl, then Cl, then here Cl and Cl. At the same case, here what is the answer? Answer is, this is the answer. At the same case, if you asked what is the boiling point order? Boiling point of the compound depends upon 4 factors. One is boiling point depends upon general, the organic or inorganic, depends on 1 hydrogen bonding. Hydrogen bonding is the first criteria for boiling point. Hydrogen bonding is the first criteria. Second one is, then what is that? Molecular mass. Next one is polarity. Next one for isotope, surface area. These are the 4 points to explain the boiling point of the compound. Here we go to this is melting point, boiling point, two are different criteria. This is packing capacity. Closeness, packing capacity increases, melting point increases. This one is nothing but hydrogen bonding is a criteria. Here there is no hydrogen bonding. Next, there is no importance of molecular mass, same molecular mass. Then is not a open chain compound. Here criteria goes to the polarity. So here then Cl and Cl, this is a polarity Cl, then Cl, here Cl and Cl. In this case, what is the highest? Then this is the polarity is high, then this is ortho greater than, para greater than meta. This is it's a reverse. In both the compounds, in both the samples, that means either melting point or boiling point, meta is the least. Then you go to the meta is the least. Here boiling point also, this is a boiling point order. Boiling point order. Why this is a less polarity? So polarity is 0. Here polarity is 0. But here compared to polarity, what is the content of this one? Then this is boiling point is depends on 4 factors. Then in this one, what is the criteria? Ortho greater than, para greater than meta. In both melting and boiling point, this is meta is least. In case of melting point, para greater than ortho. In boiling point, ortho greater than para. Okay, na? Next one. The protein is what is the molecular mass of protein? Proteins are polymers of alpha amino acids. Alpha amino acids. What is the alpha amino acid? RCHCOOH. Carboxylic acid, adjacent carbon has NH2. This is called amino acid. This is alpha amino acids. Here we go to there. Here NH2, here this is there. This is not a alpha amino acid. Next one. This is side one. So this is alpha amino acid. Next one is, this is not a alpha. This is not a alpha amino acid. Okay, no? Next one, this is not a alpha amino acid because it's not a alpha amino acid. So what is the option? Option is this one. Clear? Okay. Next one is, which transition in the hydrogen spectrum would have same wavelength of Baumol? I will give the one easy trick. What is that? Hydrogen, then 2 to 1, transition from 2 to 1. Next one is helium plus, what is the Z value? Z equal to 2. This Z value is multiplied by both sides. That means both sides. This side 2 into 2 is a 4. Then is multiplied by 2 is a 2. Similarly, lithium plus 2. What is the Z value? Z equal to 3. This is multiplied by both sides. What is that? 3 into 2, 6. Then 3 into 1, 3. Similarly, beryllium plus 3 is given. Z equal to 4. Then is multiplied by both sides. What is that? 8 is a 4. So all these samples have same wavelength. I am showing that this is the easiest trick. Then, so for this one, what is the answer for this one? Answer is here, hydrogen 2 to 1. Then transition for hydrogen 2 to 1. This is the option. Okay. I am showing that nu bar equal to 1 by lambda equal to R Z square into 1 by n1 square minus 1 by n2 square. This is. We go to for hydrogen. I am taking hydrogen. 1 by lambda equal to, what is the R value? R into Z 1 square into 1 by, I am taking 2 to 1. Is a 2 to 1. 1 square minus 1 by, what is that? 2 square. This is R into 3 by 4. Therefore, lambda equal to 4 by 3R. Is okay na? Next we are going to the helium plus, what is that? It's a double. 4 to 2. What is that? 1 by lambda equal to R into 2 square into 1 by 2 square minus 1 by 4 square is equal to 4R into 1 by 4 minus 1 by 16 is equal to 4R. This is 16. This is 4 minus 1 equal to 4R into 3 by 16 equal to 4 equal to 3R by 4. Therefore, lambda equal to, what is that? 4 by 3R. Clear? This is a calculation. Don't go to this kind of calculation in examination hall because the time waste process. Easiest is this one. Is it clear? Okay. The next one. Next. Here, column 1 and column 2. Mixture of compounds and separation techniques. Here, this is water. This is a high density compound. Two different density compounds are separated by using, what is that? This is this one. So, A, B, C and D. Now, what is that? Differential. This is a 2. 2. Oh, here two options are there. Then we go to this one. Sodium chloride and what is that? Glucose. These are separated by crystallization. Solids are separated by crystallization method. A mixture of solids are separated by two methods. One is crystallization, second one is sublimation. Sublimation is used for volatile compound. Here these are not a volatile compounds. So, what is that? This is 1. So, is, what is that? Only one option. Then next one is, okay. So, option is this one. What is the next one? Then these are separated by, this is a kerosene, naphthalenes are separated with the fractional distillation process. Fractional distillation, that is a 4. Remaining B is, what is that? 3. 3 is nothing but column chromatography. Option is this one. Okay. Get any kind of confusions, these select easy method. This is a better method. Okay. Next one, increasing order of radius. Everyone knows. Then positive charge increases. Positive charge increases. Positive charge increases. Size decreases. Next one is here, negative charge increases, size increases. That's why here, what is the law? Ca plus 2 is less than K plus less than Cl minus less than S minus 2. Is okay na? Answer is this one. Next one. Here, H2O2 act as reducing agent. Then, what is the easy trick? What compound is given, don't go to that side. For suppose, I give a simple example. Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu is a question, for suppose. In this one, what is the role of zinc? Zn, what is the role of zinc, he asked. That's why my point is, don't discuss about this one. You discuss about the remaining part. This is goes to this side. What is that? This is a plus 2 to 0. This is a reduction. That's why this is called reducing agent. That is, for suppose I want, what is the rule of copper I want? Copper plus 2. What is the rule of copper plus 2? What is the rule of copper plus 2? That's why don't consider this one. Here 0, this is a plus 2. What that? This process is oxidation. That's why this is called oxidizing agent. This is an easy trick for identification. So now we are go to that. Now what is that? What is the oxidation state of Cl? This is Cl is NOCl minus. What is the oxidation state? O plus Cl equal to minus 1, minus 2 plus Cl equal to minus 1, Cl equal to plus 1. Here is a plus 1, this is minus 1. Here I want this one. You close this one. Don't go to that side. Then this is, what is the process? This is reduction. That is a reducing agent. Next one. Here this is a plus 2, this is a plus 3, this is oxidation, this is reduction. This is, what is the process? This is oxidation. That's why this rule is oxidizing agent. Here also same. This is a plus 2, here plus 4, oxidation, this is oxidizing agent. Then this is a minus 2, this is a plus 6, oxidation is a oxidizing agent. This is the easiest method than regular method. Okay, na? Answer is this is. Next one. Which of the following artificial sweetness has the highest sweetness value compared to cane sugar? Okay, na? This is very easy. Then AS, SA, then Alti, then Alitam, then AS, aspartame. Aspartame is 100 times more sweeter than this one. Next one is saccharin. Saccharin is 550 times more sweeter than. Then sucralose, this is around 600, is a alitam. Here this is alitam. Okay, na? Like ultimate sweetness, like ultimate, just for coding. Alitam is ultimate sweetness. What is that? This is 2000 times more sweeter than regular cane sugar. So what is our answer? This is alitam. Alitam is ultimate sweetness compound than what is the sucrose. Clear? Next one, XCF4. Then hybridization equal to half into number of valency electrons plus number of hydrogens and halogens minus cation plus anion. This is one of the easy method. Number of lone pairs equal to, that is, minus surrounding atoms. SA means, H means this is. SA means surrounding atoms. Okay, na? Some limitations are there. Almost 99% compounds obey this formula. Then except ClO2 and that is a NO2, then some NO. These two compounds can't explain by using this formula. Rest of all compounds, 99.9% compounds are explained by this kind of formula. Easiest method. So here what is the valency? You take first group, second group, 13th group, 14, 15, 16, 17, and 18th group. What is the valency here? This is NV means number of valency electrons. Valency electrons. Number of valency electrons. First group 1, here 2, 3, 4, 5, 6, 7 and 8. What is the reason? NS1, NS2, NS2, NP1, NS2, NP, what is that? 2, NS2, NP3, NS2, NP4, NS2, NP5. This is NS2, NP6. This is the related data for the formula. Okay, na? This is. Now I am going to the, what is the first one? First one is XeF4. XeF4. Half into group valency electrons 8 plus number of halogens. Here 4 equal to how much? 6. What is the hybridization? sp3d2. How to identify sp, sp2, sp3, sp3d, sp3d2? Like here, what is the sum? 1 plus 1, 2. 2 means sp hybridization. 1 plus 2 equal to 3 is a sp2. H equal to 2, H equal to 3. 1 plus 3 equal to 4. 1 plus 3 plus 1, what is that? 5. 1 plus 3 plus 2, here 6. That's why this is. Here, what is the value? H equal to how much? H equal to how much? 6. 6 means what is the hybridization? sp3d2. How many lone pairs are there? H minus surrounding atom. What is the H value? 6 minus surrounding atoms 4. So this is 2. What is the type of molecule? Type. That is A, central atom A, visibility A, surrounding atoms B4, and how many lone pairs are there? 2. So what is the type of this one? AB4E2. AB4E2 means square planar. Square planar. And then, so what is the one square planar means? What is that? This is a 2. A2. Next one. Second one is SF4. H equal to half into 6 plus 4 equal to 5. sp3 5. 5 means what is that? sp3d. Lone pairs equal to how many? 5 minus, okay, na, surrounding atoms 4 equal to 1. What is the type of molecule? What is the visibility? A is a central atom. Yes, A. Surrounding atoms fluorine, so 4. That's why that is a A, that is a B4. How many lone pairs are there? 1. This is, that's why this is seesaw. Seesaw. Or the seesaw, this is B equal to 1. Next one, NH4 plus. NH4 plus half into, then what is that? 5 plus 4 minus 1, minus cation, loss of electron, equal to 4. 4 means sp3. How many lone pairs are there? 4 minus surrounding atoms 4, 0. What is the type of this one? AB4. What is the shape of this one? Tetrahedral. Tetrahedral. Okay, na? Next one. Tetrahedral means what is that? This is a 4. Next one is Br. What is that? F3. Then hybridization equal to half into, then 7 plus 3 equal to 5. 5 means sp3d. How many lone pairs? 5 minus surrounding atoms. How many surrounding atoms? 3 equal to 2. What is the type? This is Br A. Then F3 surrounding atoms B3. How many lone pairs? 2. 2. That is why this is a T shape. Then T shape. Okay. So what is the option for this one is a 3. What is the 2 1 2 1 4 3? Option is here 4. And now here trans compound is converted into cis compound. So here this is given compound, trans compound, that is a PH CH double bond CH3 is treated with bromine. We get CH3. This is Br and Br. Then next one is here treated with alcoholic KOH. Alcoholic KOH and heated is a removal of one dehydrohalogenation. Only one hydrogen and one Br is removed. That's why PH, then C double bond, then CH3Br. CH3 here Br, or that is our choice. What is another choice? What is the compound is PH CBr double bond CH3. Any one. Now one more molecule of one more. What is that? Dehydrohalogenation NaNH2 sodamide and heated. One more molecule HBr is removed. We get then P C triple bond C, then CH3. Now this is treated with Lindlar's reagent. Then is a Lindlar's palladium, barium sulfate and quinoline. This is called Lindlar's. What is the Lindlar's cis product? Then partial reduction H2 in the presence of Lindlar's. So it gives the cis product CH is a double bond CH3. Here hydrogen and hydrogen. This is a cis product. So compound is subjected to bromination. Next one is dehydrohalogenation 2 times. 2 molecules of HBr is not removed by KOH. That's why we are using first KOH. Next one is removed by sodamide. Next treated with Lindlar's reagent. So what is the proper answer? Br2 alkalic KOH H2 in the presence of Lindlar's. What's the answer is this one. Okay, na? The adding of surfactant in non-polar solvent. Here non-polar solvent. Then in our NCERT is given polar solvent. What is the polar and non-polar is reverse, na? Then that is a methyl this is here in the presence of polar solvent in water, that is polar solvent. So in this one we get this is a head part, this is okay. Its non-polar solvent is a reverse, non-polar. That means this is in non-polar solvent. Non-polar solvent is a reverse. That means here this is the content. So option is this one. So this is the option. Okay, na? Polar or non-polar. The next one is organic compound as the empirical formula is, what is that? C6H6O. You can subtract C6H5, we get a compound. Then what is that? Hydrogen OH. On the benzene ring, what is there? On the benzene ring, OH is there. That is nothing but phenol. Is the phenol. Clear? Now this is treated with bromine in the presence of here. Bromine in the presence of, what is that? Low polarity solvent. What is the low polarity solvent? CS2. Then we get two products are possible in that one. OH, this is Br plus this is OH and Br. Due to bulky, this is a less stable, this is a more stable, is a major product. So what is the highly yield product? Answer is this one. Clear? Next one. The correct statement of hydrolysis of brine solution. What is the brine solution? NaCl, aqueous solution. So it has, that means Na plus Cl minus H plus and H plus from water, OH minus N from water. These are the contents, constituent ions in the solution. At anode, oxidation takes place. Oxidation. That means here Cl minus gives rise to Cl2 plus 2 electrons is a possibility is there. One possibility. And another second possibility is, what is the second possibility? H2O, you apply the over potential, gives rise to then O2 gas plus 4H plus 4 electrons is a possibility is there. Then this is how many? 2. These are the anode. What is that? Cl2 at cathode, this is wrong. Oxygen at cathode, this is wrong. What is the next one? Next one is at cathode. What is the cathode? Here water. This is a alkali metal, is active. That's why H2O plus 2 electrons gives rise to H2 plus 2 OH minus. That is, so anode, these 2 OH minus ions, 2 Na plus ions combine with 2 OH minus ions gives rise to 2 NaOH. This is the cathode product. Hydrogen gas at anode is wrong. Okay, no? Then OH formed at cathode. This is the answer. Clear? Next one. The logarithmic equilibrium constant for the reaction is given. Okay, now listen. Here E cell equal to E0 minus 0.059 by N log quotient. That is, at equilibrium state, what happened? E cell equal to 0 and quotient equal to equilibrium constant. That's why here what is the value? E0 value is 0, and then E0 minus 0.059 by n log equilibrium constant. So E0 equal to, I am taking roughly 0.06 by n log equilibrium constant. What is the required? Required is log k equal to then n into E0 by 0.06. That is the required. Okay. Then how to calculate remaining part? This is what is the next part. So we want to find out n value and E0 value. What is the anode reaction? Here two products are given. What is that? PD plus 2 plus 2 electrons gives rise to, what is that? PD solid. What is the E0 value? E0 equal to E0 0.83 volt. That is okay na. Next one is, I am changing to delta Z0 1 equal to, what is the delta Z0 equal to minus NF E0 cell. Now minus NF, what is the n value here? N value, this I am taking 1, equation 1. I am taking equation 1. Then this is, what is the n value? 2. 2 into F, what is the E0 value? 0.83. This is the equation 1. What is the next one? Next one is PdCl2 PdCl4 minus plus 2 electrons gives rise to what is that? PD solid plus 4Cl minus aqueous. What is the E0 value? E0 equal to 0.65 volt. This is okay na. What is the next equation here? Delta Z0 2 equal to minus, how many electrons are participated? 2 into F into E0 value 0.65. This is volt. Now how to get this equation, this original equation, by using these two equations, either addition or subtraction? This is the original equation. So I am go to the then go to the subtraction. Minus minus minus, this is a minus here, this is a minus. Okay, this one cancel, this is a cancel. Then what is the net equation? This is PD plus 2, okay na, plus 4Cl minus, these are coming to this side, 4Cl minus aqueous gives rise to, then what is that? This is coming to that side, PdCl4 minus. What you are applying? Delta Z0 net value equal to, what mathematical application you applied? Subtraction. Same method you applied. What is that? Delta Z0 1 minus delta Z0 2. Okay. And now what is the nth value? How many electrons are participating in this one? 2 electrons. In this equation, how many electrons are cancelled? 2. So minus n, what is the n value? N value equal to 2 F E0 cell value, okay na, is equal to, that is a net value, is equal to minus, what is the value? 2 F into 0.83 minus of minus, that is a plus, minus 2 F 0.65. That means this is negative value cancel. What is the 2 cancel? E cell net value equal to, what is that, 0.83 minus 0.65. Therefore, 0.83 minus 0.65, this is 8, this 7, 1, 0.18. 0.18 volt this is. So in this case our required is, this one is the required, this is a required value. Therefore this is a equation 1, this is a equation 2. From equation 1 and 2, from equation 1 and 2, from 1 and 2, what is the value? Log k equal to log k. What is that? What is the n value in this equation? This is a 2 electrons are participated. 2 into, then 0. What is the value? 18 by, what is this value? 0.06 equal to 2 into 18 by, what is that, 6, 3. What is the value? Is a 6. Okay na? 51 answer is 51 answer is 6. Okay. Here why you are applying this one? Why don't go to the direct? Don't go to the direct because E cell value is intensive property. E cell value is intensive property. That's why one equation is added, multiplication you never change the value. That's why intensive property changes to extensive property, then you are going to the calculation. Don't go to the direct application. Clear? Next one. What is that? The rate constant of above 200K and 300K is given. What is the activation energy? According to Arrhenius equation, Arrhenius equation, what is that? Log K2 by K1 is equal to EA by 2.303 or 1 by T1 minus 1 by T2, that is 1 by, what is the K1 value? K1 equal to 0.03 minute inverse, K2 equal to 0.05 minute inverse, then R equal to, what is the T1 value? T1 equal to 200, T2 equal to 300, that is nothing but T2 minus T1 equal to how much? 100. Then R equal to given, what is the R value? R equal to 8.3. R equal to 8.3. So you substitute in this. What is the Arrhenius equation? Log K2 by K1 equal to EA by 2.303 or T2 minus T1 by T1 T2, that is. Okay na? So what is the value of this one? Log K2 by K1, that is 0.05 by 0.03 EA by 2.3 into what is that R value? What is the R value? 8.3 into T2 minus T1, 100 by 200 into 300. So here these two is a cancel. Log that is a 5 by 3. Then log 5 minus log 3 equal to 0.70 minus 0.48. So this is a 2, this is 6, 0.22. Therefore, this is a 0.22 into 2.3 into 8.3 into this is, here coming to this side, what is that? 600 equal to activation energy. Okay, no? You can calculate this activation energy equal to, what is the value? This is 2520, that is a joule. Original accurate value is 2519.88. Okay, na? Answer is 2520. Okay, na? Okay. Next one. Enthalpy change of conversion of half Cl2 to Cl minus in aqueous. So then here half Cl2 gas gives rise to then Cl gas, that is D by 2 value. This half mole is there, dissociation enthalpy. Next one is this is changes to Cl minus ion, then that is electron gain enthalpy. What is the next one? This is treated with water. We get water. Cl minus ion aqueous. This is hydration enthalpy. Value is negative. This is electron gain enthalpy is negative. This is endothermic is a positive. This is a positive. Okay, na? We want to find out half Cl2 gas molecule into Cl minus aqueous solution. Okay, na? Here how many stages are there? Chlorine gaseous molecule convert into chlorine gaseous atom, that is a bond dissociation enthalpy or atomization enthalpy. Next one is chlorine gas is converted into chlorine gaseous ion, that is called electron gain enthalpy. Gaseous ion converted into its aqueous solution, that is called hydration enthalpy. How much values are given here? This is, we want D by 2 value. What is the D by 2 bond enthalpy value? 240 by 2 equal to 120. That is a kilojoule per mole. Next one. What is the electron gain enthalpy? Minus 350. What is this value? Minus 380. This value equal to positive. This is a negative. What is the net value? This total value is 380 plus 350. 0, 3, 700 minus 730. Here plus 120. What is the net value? Net value equal to 120,016. Therefore, minus 610. What is the value in joule? Kilojoule per mole. So, what the answer is? 610. Okay, na? 53, 610. Okay. Next one. The complete combustion of 0.492 grams of organic compound gave 0.792 grams of CO2. What is the percentage of carbon in organic compound? According to Lebig's method, percentage of carbon is equal to 12 by 44 into weight of CO2 by weight of organic compound into 100. Okay, na? This is qualitative and quantitative analysis of organic compound. That means purification of organic compound. So this is 12 by 44 into, what is the CO2 value? 0.792 by 0.492 into 100 is equal to 12 by 44 into 7.92 by, this is a 4.92 into 100. This is around 43.90%, is approximately 44%. Is it clear? Okay. Next one. At 27 degrees Celsius, a solution containing 2.5 grams of solute. So what is the molar mass of the solute? R equal to is given. Okay, now here what is the given? This is in Pascal, is given. This is in bar. This is in bar. So 1 bar equal to 10 power 5 Pascal, or 1 Pascal equal to 10 power minus 5 bar. Okay, this is one part. This one. First one is, we required pi equal to CST or CRT, that is. Therefore, what the C is required first? What the molarity equal to? Here molarity equal to C equal to weight by molecular mass into 1000 by V. Here C equal to, what is the weight is given? 2.5 into, this is the required, into 1000 by, what is the value? This is 250, equal to how much? This is a 4. Therefore C equal to 10 by x. Therefore 10 by x. Okay, no? This is a required. First we calculate the C value from this one, the substitute you get an answer. Okay, no? This is equation 1. I go to equation 2. What is the pi value is given? What is the R value? R equal to how much? 0.083. What is the T value? 300. What is the RT value? Then 0.083 into what is that? Is a 300 is equal to 8.3 into 3 equal to 9. This is 24. That means around is a 25. Okay, na? This is a RT. What is the C? Is a pi. Is a pi. What is the pi value? Pi equal to 400. Then Pascal is given. Here 4 into 10 square into 10 power minus 5 bar is equal to how much? 4 into 10 power minus 3 bar. You substitute there. Then C equal to pi by RT. Pi by RT. What is the pi value? 4 into 10 power minus 3 by, what is the RT value? 24.9. This is 2. From 1 and 2, this is from 1 and 2. From 1 and 2, what is the C value? This is a 4 into 10 power minus 3 by 24.9 is equal to 10 by x. Therefore, what is the x value? X equal to 249 by 4 into 10 power minus 3 equal to 249 by 4 into 10 power 3. This is, you can calculate, that is nothing but 24.9 into 10 power 4 by is a 4. That is a 6.225 into 10 power 4 equal to 262,250. That is a molecular mass. Okay, na? Okay, this is answer is 62250. Next one. Zinc reacts with hydrochloric acid, gave hydrogen gas and zinc chloride. Then at STP, how much quantity of hydrogen gas is evolved? That is required. Zinc reacts with HCl to give hydrogen gas and HCl. The volume of hydrogen produced at STP is when 11.5 grams of zinc is treated with excess of HCl. What is the question? Zn plus HCl gives rise to ZnCl2 plus H2 gas. This is a question. Then here you take here 2. What is the standard values? Standard values are, this is what is required to us, zinc versus hydrogen gas is required. Zinc versus hydrogen gas. What is the standard values? This is 1 mole. This is 1 mole. We required in, what is the required volume of gas at STP. What is the molecular mass? What is the molecular mass is given? Zinc value is given, that is 65.4 grams is nothing but STP 22.7 liters. What is the given condition? Is the given condition is 11.5 grams equal to how much volume? Therefore, volume of H2 gas at STP equal to 22.7 into 11.5 by what is 65.4. This around 3.99 around is nothing but around 4 liters. Okay, na? Okay. First you take equation. This kind of questions you can solve in 4 steps. Step 1, making of equation formation. Second one, step 2, marking. Step 3, standard values. Step 4, given values. Here step 5 is answer. This is very easy method to solve the stoichiometric or mole concepted questions. So first I create the equation. This is the equation. Next one is a marking. What is the required? What do you want to find out? Here 3 type of numericals are there. One is weight relation, weight volume relation, volume relation. Here in the given numerical, given data is weight volume relation. This is a weight, this is a volume. That's why I am taking in, this is a weight molecular mass, this is a volume, that is in STP. So the marking completed. What is the standard? Here how much is there? 1. Here 1 is there. That's why this is a 1. Here how much is there? 1. That's why this is a 1. Next one. These weights are given. That's why 1 mole changes to weight. What is the weight molecular mass? This is given. Here you ask in volume. That it changes to volume. This is a volume. Now what is the next step is given. This is given. Okay. So this is given. What is the next step? Answer calculation part. This is an easy trick to calculate the numericals. Okay. Na? Next one. How many compounds gives aromatic amine? Aromatic amine means here aniline, like that. Here what is that? This compound, this is Hofmann bromamide reaction. Bromamide reaction, degradation. Hofmann bromamide degradation. So here this is removed, we get aniline NH2. So this is correct. Next one, this is Gabriel Thalamide method. Gabriel Thalamide method. Thalamide method. This is not applicable for formation of aniline and aromatic amines. That is okay, na? So this is wrong. Now next one is, this is reduction 6 hydrogens, it changes to aniline. This is correct. Next one is a hydrolysis. NH double bond O CH3 subjected to hydrolysis. Here this is a H, this is a OH. We get aniline and formic acid. So this also possible. Okay, na? Answer is 3. In Gabriel Thalamide method, we can't prepare this one, but we can prepare this one. Can prepare. This is not possible. That's why here this is not involved in the reaction. This is a SN reaction. Halobenzene is not involved in SN1 or SN2 reaction. This is especially Gabriel Thalamide method is SN2 reaction. So CH2 double bond CH Cl these three compounds here Cl, these three compounds never involved in either SN1 or SN2 reaction. One of the important bits. That's why this is a SN2 reaction. Vinyl, then chlorobenzene never participate in the reaction. Is it clear? So this is a compound. Okay, na? Answer is 3. Answer is 3. Next one. SO2 plus half O2 gives rise to SO3. We want to Kc. Then SO2 plus half O2 gives rise to, what is that? SO3. That is, this is a gas, this is a gas, and this is a gas. What is the delta N value? Delta N equal to moles of gaseous products minus moles of gaseous reactants. Gaseous reactants. There. So here this is what the value 1 minus this is a 1 is a coefficient 1 plus half equal to minus half. That is okay, na? This one. So Kp equal to Kc into RT power delta N. Now what is the RT value? What is the R value? R equal to 0.082. Next one is a T is given. T equal to 300. Therefore, RT equal to, okay na, 0.082 into 300. 2 points cancel. 8.2 into 3 equal to 6, 24.6. That is around, I am taking this is 25. Is that 25? Now this is Kp equal to, what is the Kp value? 2 into 10 power is it 12 equal to Kc into, what is that, RT power 25 power minus half. This is coming to this side. Kc equal to, what happened, 10 power 12 into 25 power half. What is that? Then 2 into 10 power 12 into 5 equal to 10 into, this is 10 into 10 power 12 equal to 1 into 10 power 13. So what is the required answer is here, this value, answer equal to 1. Clear? Next one. The oxidation state of phosphorus in hypophosphoric acid. Here, this is hypophosphoric acid. I give the simple trick without any structure. Then H3PO4 is there. Okay, na? I want metaphosphoric acid. Metaphosphoric acid. Next one is then hypophosphoric acid, pyrophosphoric acid. I want this is hypo. You know this oxidation state. Hypo means, what is that? Meta means compound minus H2O minus H3PO4 minus H2O. What is that? HPO3. That is. Now here what oxidation state is there? What is the oxidation state? What is the oxidation state of phosphorus? This is a plus 5. This also plus 5. Plus 5. Next one. We are coming to this. Hypo means double minus H2O2. H3PO4 is a double minus H2O2. Then is a double minus H2O2. Here this is double minus H2O. That is. What is the double? Here, what is the double? H6P2O8 minus H2O2. What is the compound? H4P2O6. Then this is a formula. Here H6 what is the compound? This is H6 P2O7. What is the oxidation state of phosphorus? Plus 6 plus 2P minus 14 equal to 0. 2P equal to how much? 14 minus 6. What is the value? What is the value of this one? We are coming to this one. Next, what is the value of this one? Plus 4 plus 2P plus minus 12 equal to 0. Then plus 4 plus 2P minus 12 equal to 0. 2P equal to that is 12 minus 4 equal to 8, then P equal to plus 4. And here what is the value of this one? Then this is H4 P2O7 plus H plus 2P minus 7O equal to 0 plus 4 plus 2P plus 14 equal to 0, 2P equal to plus 10, P equal to plus 5. So here anywhere phosphoric acid, metaphosphoric acid and pyrophosphoric acid and phosphoric acid, 3 are same oxidation state. Important points: phosphoric acid, metaphosphoric acid, then pyrophosphoric acid. What is the hypophosphoric acid? How to find the hypophosphoric acid? Phosphoric acid need not write any structure. Phosphoric acid, its double minus H2O2 is nothing but hypoic acid. Double minus H2, here H2O2, here H2O is there, that is a pyrophosphoric acid. Compound minus H2O is there, that is metaphosphoric acid. Okay, na? That is generally for tribasic acid, this is a possible. Tribasic acid. For sulfuric acid, metasulfuric acid is not possible. Okay, na? So for our answer is, what is the answer? 4. Answer is plus 4. Okay, na? Next one is total pressure of the mixture non-reacting gases. What is the required to partial pressure? What is the partial pressure? Partial pressure equal to mole fraction into total pressure. Total pressure. Okay, na? Is the total pressure. Then what is the mole fraction? Here X gas is there. We go to the X. This is the formula. And then X moles of X, that is the NX, weight by molecular mass. What is the weight is given? How much? 0.6 by, what is the molecular mass? Molecular mass of X equal to 20 is equal to 6 into 10 power minus 1 by 2 into 10 that equal to 3 into 10 power minus 2 or 0.03 moles. What is the next one? Y gas is there. Y. Moles of Y equal to, what is the weight? 45 into 10 power minus 2 by, what is the molecular mass? 45 is equal to 1 into 10 power minus 2 is equal to 0.01. Then total moles equal to Nx plus Ny equal to then 0.04 or 4 into 10 power 4 into 10 power minus 2. Next, mole fraction of what is the required? Required partial pressure of X equal to mole fraction of X into total pressure. Then what is the mole fraction value? Mole fraction equal to Nx by Nx plus Ny into total pressure. What is the Nx value? Nx equal to 3 into 10 power minus 2 by, and then this is total equal to 4 into 10 power minus 2 into, what is the total pressure of the gas? This is a 740 equal to 3 by 4 into 740 equal to 0.75 into 74. 7.5 into 74 equal to 555. Okay, na? Answer is 555. Okay. Thank you.